Hi everyone! This video is part 2 of talking about interior and exterior angles of polygons. If you have not watched part 1, you should go and do that now. So in this video we are going to talk about the exterior angle measures of polygons. And the exterior angle measures of polygons is actually shockingly simple, because the exterior angle measures of any convex polygon is just 360 degrees. If you want to know why that is and you want to see some examples, you can watch some other videos that talk about where this comes from. But any polygon that is convex, the exterior angle measures will add up to 360 degrees. So we can do a lot of math with this. For example, in this shape, in example 1, I have a quadrilateral, right? 1, 2, 3, 4 sides, and they want to find the value of x. Well, they tell me all 4 exterior angle measures. Notice that the exterior angles are not the entire thing on the outside. It's formed by extending each side and measuring the angle. I know that these 4 exterior angle measures are going to add up to 360 degrees. So I can do 13x plus 49 plus 21x minus 40 plus 113, and that's going to give me 360. To solve this equation, I'm going to start by combining my like terms. So I have 13x and 21x, which is going to be 34x. Then I've got 49 minus 40 plus 113 is 122. I'm going to subtract 122 on both sides. So we're going to do 360 minus 122, and we get 238. So we get 238 equals 34x. And then I can divide both sides by 34, so I get 238 divided by 34, and we get that x equals 7. So in this problem, the most challenging thing was doing the algebra, because since it's exterior angles, they are always going to add up to 360 degrees, no matter the number of sides on our figure. If we look at example number 2 talks about a convex hexagon. We might want to remember that a hexagon means that it has 6 sides. And the exterior angle measures in degrees are 42, 55, 73, 41, and 50. And then they ask us, what is the measure of the 6th exterior angle? Well, I know that all of the exterior angles are going to add up to 360. So that would be 42 plus 55 plus 73 plus 41 plus 50. And that is going to, if I add my unknown 6th angle, that is going to give me 360. So I'm going to take my calculator and add up all of those numbers. We have 42 plus 55 plus 73 plus 41 plus 50. That gives me 261. So I know that 360 is going to be 261 plus x. And if I subtract 261 on both sides, I get that x equals 99 degrees. So that missing angle is 99 degrees. So we now know that the exterior angles of any polygon add up to 360 degrees. We can also talk about each exterior angle measure, just like we did with interior angles. And in a regular polygon, so once again, remember that a regular polygon is where all of the angles are the same, then we can calculate each exterior angle by taking that 360 and dividing it by the number of sides we have, because that'll be the number of angles. So 360 divided by n will tell us each exterior angle. To use this in the problem, they ask us to find the measure of each exterior angle of a regular 11gon. So I know that n equals 11. To calculate each exterior angle, I'm going to do 360 divided by 11. And if I use my calculator, 360 divided by 11, that's going to be about 32.73 degrees. In this next example, they tell us an exterior angle of a regular polygon has a measure of 45 degrees, and they want us to classify the polygon. When they say classify the polygon, they're asking us how many sides. They're asking us what type of shape it is. So I know that 45 is going to equal 360 divided by n. Because this is really a proportion, I can switch these numbers. We could also multiply both sides by n and divide by 45. So n is going to be 360 divided by 45, which equals 8. So this is going to be an octagon, because that is a shape that has 8 sides. If you want to see how we did that, I can show off to the side. So 45 equals 360 over n. I can multiply both sides by n, so we get 45n equals 360, and then we divide by 45. And we get n equals 8. Notice that this is the same thing as just switching those two numbers. We end up here. I do want you to notice for a moment that we calculated in the previous video that the interior angles of a regular octagon were 135 degrees. Now that should make sense, because if we look at interior and exterior angles, notice that they do form a line. They form 180 degrees. So if you know the exterior angles, you can calculate the interior angles, and vice versa. This is nice because sometimes it is significantly easier to calculate the exterior angles than it is to calculate the interior angles. Let's do one more example together. An exterior angle of a regular decagon has a measure of 4x. What is the value of x? So first off, decagon we know has 10 sides. So to find out each exterior angle, I could do 360 divided by 10, which is 36 degrees. So if each angle is 36, then I know that 36 is going to be equal to 4x. So I can divide both sides by 4 and get x equals 9. So the trick in this problem was to divide both sides, or to figure out what the exterior angle is, and then set that equal to the expression that they gave me, which in this case was 4x. And that is how we calculate the exterior angles in a polygon. Thank you guys for watching.